Okay guys, today we're going to focus on the very last part of your linear and quadratic parent function assignments, which is called Test Yourself. There's 8 questions and I'm going to go over a few of them. Question number 1. What is the parent function of this graph? Remember, in real life you have 2 parents. Well, in Algebra 1 we're only going to look at 2 parent functions. Linear parent function and the quadratic parent function. If you're looking at a linear function, you're looking at something with a line, something in the shape of a line, something that looks like that. If you're looking at a quadratic function, because you have the letter U, you're looking at something in the shape of a U. And looking at this graph, we can already tell that this is not a line, so it's not, the linear parent function is not its parent. It's in the shape of a U, and it's in the shape of a U that's upside down. So the quadratic parent function is its parent, and although A would be the equation that would give us this function, because we're looking for the parent function, the equation for the parent function of a quadratic is y equals x squared. So our answer is B. Number 2, which of the following is a quadratic function? If I'm looking at a quadratic function, again, I'm looking at something in the shape of a U, because I have the letter U in quadratic. And more specifically, I'm looking at anything that has x squared in it. Something to get more specific, something in the format of y equals x squared. It's not A because we have 3x to the 4th power. It's not B, we don't have an x squared there. It could be C, and it's definitely not D because we don't have any x squared in there. So our answer has to be C. We have 2x squared minus 3x plus 6. Number 3. What is the parent function of the following points? Anytime you're given points, the very first thing you want to do is make yourself a table. So I have 1, 2, 5, 6, 6, 7, 12, and 13. I'm looking at what is the parent function. Remember, you only have 2 parents. You have the linear parent function, which its equation is y equals x, and the quadratic parent function, with its equation as y equals x squared. And right away we can already tell it's not A, and our answer is not B because we're only looking at the parent functions. To figure out whether this is quadratic or linear, I need to take the rate of change. The rate of change is the difference between the x and the y. To get from 1 to 5, I add 4. To get from 2 to 6, I add 4. The rate of change is the change in y. In this case, that's 4. Over the change in x, which in this case is also 4. 4 divided by 4 will give us 1. Let's see if our rate of change is constant. The rate of change between 5 and 6 is 1. The rate of change between 6 and 7 is 1. 1 divided by 1 is 1. So my rate of change is constant. In other words, my rate of change is the same, which means that this equation has to be a linear function. Number 4 is very similar to number 3, so I'm going to skip it. Number 5. Which of the following has a linear parent function? So on this one, I actually have to look at all my 3 answer choices. I need to start by drawing myself a table because I'm given points. 1 and 2, 5 and 6, 9 and 10, and 10 and 11. The difference between 1 and 5 is 4. The difference between 2 and 6 is 4. The rate of change, which is the change in y, which is 4, over the change in x, which is 4, that's 1. If I take the rate of change again, the difference between 5 and 9 is 4. The difference between 6 and 10 is 4. The rate of change is the change in y, which is 4, over the change in x, which is 4, which gives me 1. So right away I can already tell that the rate of change in 1 is constant. It stays the same. So that is a linear parent function that works. Number 2, I don't have anything squared. And I can actually rewrite this as y equals negative 6x plus 3 if I wanted to, which would give me a line in B, so that works. 3, I have an x squared right there, which would indicate a quadratic function, which means that's not linear. So the only ones that work are 1 and 2, so my answer is B. Remember, to be a linear function, it's either going to be a line, it's going to be a line, and if you graph it, if you look at the table, the rate of change is going to be constant, and you would never see something with an x squared in it. Number 7, which of the following is true about the linear parent function? Again, linear, I'm looking at line. The linear parent function is y equals x, and it looks like this. It passes right through the origin. The range is all real numbers greater than or equal to 0. Remember, if I want to look at domain and range, I'm always going to start by putting infinity anywhere where my arrows are pointing. This arrow at the top is pointing to the right. It's also pointing upwards. So I'm going to write an infinity on top, and I'm also going to write an infinity to the right. This arrow down here is pointing down, so I'm going to have an infinity below. And it's pointing to the left, so I'm going to have an infinity to the left. Negative infinity, negative infinity. If I'm looking at my range, x and y went to the doctor. I'm specifically looking at the y values. So I'm looking at the y-axis, and I can see that I'm going from negative infinity to positive infinity, which is another way of saying all real numbers. So the linear parent function, its range is all real numbers. It is not just from 0 to infinity. So it's not 1. It does go through the origin. So here's the origin. And the domain is all real numbers. Well, if we look at the domain, we can see that we're going from negative infinity to positive infinity, right? Because domain, we're focusing on the x-axis, which goes side to side. That means we have to look at the sides of our box. And in our imaginary box, because we won't really have a box, we are going from negative infinity to positive infinity, which means the domain is all real numbers. So our answers are 2 and 3, which means our answer is D. Okay guys, do the same thing for number 8. You're looking at the quadratic parent function, which means you have to start by drawing out the quadratic parent function and analyzing it. Figure out what's its domain, what's its range,